I'm going to give a technical review of the database management system, which is Databricks. So we'll start with what exactly is Databricks. Databricks is a data warehousing Delta Lake table software cloud storage technique wherein we can do multiple operations at once. We can do ETL analytics on the data. We can do development using Python and Java integrations, and we can do simple SQL querying of the Delta Lake tables and run all our analytical queries on it. Let's go into what are the data models supported. We'll give a brief about the data bricks, and then we can go further into the data, the play demo of how Databricks works and what are the practical applications offered by Databricks. So Databricks supports almost all types of data models, be it relational model, semi-structured, unstructured, streaming data, time series data, graph model, key value model, or document type model. This encompasses almost all kinds of data sources that we can have: temporal data, images, audios, video recordings, and basic row tuple based data models, as relational data models as well. The programming languages supported by Databricks for data management is SQL, Scala, and R. SQL enables us for the querying purposes. Scala gives us distributed computing advantages, and R can be used for statistical analysis on data, and for reporting and visualization purposes. Python, Java, and Shell Bash are more of development tools which help in developing programs using Python for AI, machine learning programs, Java for software development, and Shell and Bash for a system integration for and package management operations. The storage techniques in offered by DBMS. So DBMS does not offer a persistent layer of storage, but a framework on top of the user's cloud storage techniques. This could be AWS, Microsoft Azure, or Google GCP. The data lake table, that is a default storage technique of Databricks, offers all kinds of ACID transactions, optimized performance, data indexing, and all kinds of schema enforcement and evolution techniques. Coming to the last part of the technical review is how Databricks uses indexing as a technique to optimize performance, optimize input output costs, and filtering of data based upon the queries the users put in. So it uses seven types of indexing techniques, including Z ordering, data skipping, blue filter index, partitioning, the transaction log, caching, and cluster index. Z ordering is basically a physical type of clustering which uses multi-dimensional type of clustering, which can be implemented over multi columns. And the proximity index of these multi columns are stored so that the relevant tuples are co-located in one place and can be fetched all together at once, reducing the output cost whenever a filter is put over a query. Data skipping, it just skips irrelevant files using min max statistics over the delta lake tables, and therefore it dramatically reduces output costs. Bloom filter indexes skips files which do not contain specific values, and this is a probabilistic type of filtering, and this is great for high cardinality columns. The partitioning of large data sets based on few columns, which are most likely are used as indices in the partitioning index technique. Transaction log is more of a log to maintain a history of all the versions of the data, its schema changes, and the variations that the data has seen over the period of time it has been in existence. Caching is basically uh, getting the data in memory or SSD. It's basically the in memory indexing technique of Databricks, which which enables faster access to the data since it is in memory and it does not need to be fetched from the permanent storage of the data system. And finally, the clustered index uh, uses separating or bucketing of files using hash on column values. So a hash on the values in different columns is used to basically bucket certain similar types of files together, and thus these can be aggregate. And thus this type of bucketing can be aggregated with partitioning as well, and this is in together be used as clustered index technique on Databricks. So this was an overview or a brief of how Databricks works. We will now move. We will now move into the demo part of Databricks. Now, here I have made a free account on Databricks platform, and this is all. These are all the technologies that Databricks provides for a free user. We can first go to the SQL editor, wherein we can write our own SQL queries. Here I have done a bit of playing around. I've created a schema called playground and a table inside it. I've written this drop table command because I was creating the table again and again by using different column combinations, etc. So this is basically the table that I've created. It's a simple basic table with about a play which records the playing time, the players that were playing the particular game, and who was the winner in that particular game. And the primary key for this particular table can be the play time and the two players that were playing in that particular play time, since it will uniquely identify every game in that playing sequence. I've also inserted random uh, values into this table, and we can go ahead and run a particular query. We can go ahead and run a particular query just to see what it outputs. Uh, so it is running right now. We can see over here it is loading. Yeah. So here we have all the values that we have inputted in this particular query. We can see now we can do more filter based queries over here. So we can write select playtime from playground dot play, where so we want to see that we want to see all the games that player one has played. So we can write where player ID one equal to one, or player ID two equal to one. So here we will get all the rows where either of the two, player ID one or player ID two, is one. So here we can see that we have gotten an error because I have given the wrong column name over here. The name should have been player one ID. Now, one very interesting uh, thing that we get from Databricks is we can diagnose the error over here, and they provide an AI assistant which will then tell us what could have gone wrong in our query, and we can use it to debug our queries pretty quickly and efficiently. So here I'm just debugging my query and I'm running it again. I can see I've written almost the same query. Could be some syntax error. Let's see. Okay, I had given an extra underscore over there. I think now the query should run. and we got all the play times. We could also have gotten who had won. So in all the games that player one has played, we can check when did that player play that game and who won. So most of all the times player one has won. So this was a basic playing around with the data. We could also check other data sets. Okay, there is no data over here. We can check this data where we have basically we can preview this data just to see how it is, how it looks, etc. So these are all the columns in this data. We have quite a lot of columns to play around with. So let's start here. Um, so this is the table name. So let's just select all from this table and just check how it looks, etc. Just, yeah. So yeah, we have gotten pretty much the same thing. The 1,000 rows that we had gotten earlier. Let's apply some filter conditions where city name equals Singapore, and we will get only the data which has Singapore as its city name. We have only gotten 31 rows out of 1,000 rows, so this shows that only 31 of those tuples had city name as Singapore. So this is basically the latitude, longitude, date, and how has the climate been on that particular date, in that particular location. Um, Everything, the humidity, etc., the cloud cover, everything has been mentioned over here. So this was basically the SQL part of Databricks. We can now move on to seeing how Databricks logs all the queries. So these are all the logs of all the queries I've tried out, and can just see when was it run, what is the run time, the execution, and can yeah, we can go to some other queries. This did not run due to an error, so that error is also shown over here. So all the query logging can be done over here very efficiently, and we can maintain and get feedback from the queries that did not work in the history, and how was it fixed. The last part where I want to go through is the AI/ML techniques that is being offered. Also, the data ingestion can be done from multiple sources: Salesforce, SAP, SQL Server, Google Drive, Jira, webhooks, all of these places we can add data from. So, this is quite good as a data engineering tool. And the last part is the AI/ML playground, where we can add our own tools. We have models, we have already run models which are in service. So, the GPT OSS, all of these pre-trained models are at our disposal for usage. So basically, we have uh, quite a lot of use that we can get out of Databricks, the indexing techniques, the data management system, and also it has good integration with AI/ML tools as well. So it's an exhaustive and comprehensive solution to all database management systems. Thank you so much.